Hi guys, in today's video we're going to be learning how to work out two unknown values in two separate equations by solving them both simultaneously. Now this is really quite an advanced maths concept, particularly for primary level, so it's really important that you are already really familiar with algebra and you know how to do things like balance equations effectively. However, if you're comfortable with that, and you're looking for a bit of a challenge, something to bring you on a little bit further in algebra, then this could be a good next step for you. So what we've got here are two separate equations. We've got x plus y equals 12, and we've got 2x plus 3y equals 32. Now in these equations, the two x's mean the same thing, and the two y's both mean the same thing. But we don't know what they are. Our job is to find out what x is and to find out what y is using both of these equations to help us do that. Now, I'm going to go through this using a set of steps, really. I'll try and encourage your understanding along the way, but I'm going to teach this fairly procedurally, step by step, in order to bring on your understanding. So step one here, what we need to do first is we have to multiply the equations so that we find a common factor. So what we're looking for is to compare like with like. So we've got x plus y and 2x plus 3y. They're not the same. We want to be able to compare like with like. So is there a way of turning one of these equations into something else so that it shares a common value? Well, one way of doing this would be to change this equation so that the x's match each other. So if I multiply everything in this equation by 2, then what we will have is two x's in both sets of equations. So that way we've got a common factor. Why this is important will become clear in a minute, but just now all you need to know is that we need to find a common factor. So I'm going to rewrite equation A with that new common factor. So I'm multiplying everything by 2. So we've got 2x plus 2y, and that's going to equal 24. So equation A can now be written as 2x plus 2y equals 24. We can write equation B beside that, which is no different. We have that exactly the same. So equation B is 2x plus 3y equals 32. So that's step one. What we've got now is a common factor. So both of these now share a 2x between them. That's a common factor there, and that's what we needed to get. Step two then is now, once we've got a common factor, we have to subtract one equation from the other. So we're going to subtract one equation from the other. So what we're going to do is we're going to have equation B here, and we're going to take away equation A. So 2x, take away 2x, well that's just going to leave us with no x's. So equation B rewritten, 2x take away 2x, 0 x's, 3y take away 2y. Well, that just leaves us with y. Okay, so we should be working out what y is then. Y equals, well, it's going to be 32 take away 24, the answer to which is 8. So this tells us here that y in both of these equations must be 8. Okay, so what we should be able to do now is use that information. We've solved for one value already. We should be able to use that information to now solve the other value. So we know now that y equals 8. So what we can do is we could plug that in to the equation and then just treat it like a normal algebra sum. So I could do it in either of these cases. So I could do x plus 8 equals 12, or I could do 2x plus, well, 3 times 8 would be 24 equals 32. Either way, I should get the right answer. In this case, I'm going to take this equation because it's easier. There's less to worry about. So I'm now going to solve for x using equation A. So let's do that over here. Equation A, we have x plus y equals 12. But we know now that y equals 8. So it's x plus 8 equals 12. Well, if we want to balance this equation, I take off 8 from this side. So x equals 12 take away 8. Therefore, x must be equal to 4. So we've got our y value and our x value here. What we've done is we've worked out two unknowns by following the steps. We worked out a common factor. We made sure that we had the same number of x's in both cases. We then subtracted one equation from the other, and we ended up with y equals 8 once we solved for one of the values. And then lastly, we plugged that value back in. We used that value to solve for the other unknown value. Now, we can check that we're right by making sure that these values actually produce the outcome that we expect. So we know that y equaled 8. If we put 4 in here, does 4 plus 8 equal 12? Well, yes, it does, so that's correct. In this case, we have 2x, so that should be 2 times 4, well, that's 8. And we have 3 times y, so 3 times 8, that's 24. Does 24 plus 8 make 32? Well, yes, it does. So in that case, we know that both of these values work for both equations. Therefore, our solution is correct. Let's try another example here. Now, this one is a little bit more challenging, but by following the steps one after the other, we should be able to arrive at the same solution. So, step 1 is to find a common factor again. Now, last time it was really easy. We were just able to take one of the equations here and then multiply it by 2, and then we got both the x's to be the same value. This time it's a bit trickier though. I can't turn 3 into 2, and I can't turn 2 into 3. I can't turn 5y into 3y, and I can't turn 3y into 5y. So I'm in a bit of a tricky spot. However, our job is not just to multiply one of these equations necessarily. We have to just multiply to find a common factor. So we should be able to make any of these into any other number as long as they share a common factor. So, is there a common factor that is shared by 3 and 2? In other words, does the 3 times table and the 2 times table have a shared number, a shared value in it somewhere? Well, yes, it does. The answer is 6. So we could turn both of these into 6x using different methods, but then that would give us our common factor. So in this case, how do we turn 3x into 6? Well, I'm going to have to times everything in this by 2. So I'm going to have to multiply the whole equation by 2. So let's rewrite that. So equation A is going to become 6x plus, well, I'm going to do 2 times 5, so that's 10y. And that's going to equal 2 times 31, that's 62. Okay, so I've got 6x here. Now I need to get a 6x here as well. How do I turn 2x into 6x? Well, I'm going to times all of this by 3. So equation B here, we're going to end up with 6x plus, well, 3 times 3 is 9y, and that's going to give us an answer of 57 here. So we've now got two equations. They're both rewritten. They're the same equations, just written in a different way. So 6x plus 10y equals 62 would be this equation here. 6x plus 9y equals 57 would be this equation here. So we have now found a common factor. Secondly, what we need to do is we need to subtract one equation from the other. So we can do 6x take away 6. Well, that leaves us with no x's. 10y take away 9y. Well, that's going to leave us with y. And that's going to equal 62 take away 57. And now solving for that one value, so we're subtracting one from the other, solving for that one value, we should get an answer of 5. So y equals 5. So lastly, we should be able to plug in that value to solve our other unknown value. So if I take this y now and treat it as 5 in all these cases, I should be able to solve the other unknown value, which would be x. So, for instance, let's say 5y here, well that's going to be 25. 3y here, that's going to be 15. Now I can just treat these like normal algebraic equations. So, let's take this one, because it's a little bit simpler, and we'll rewrite it over here. So, we have equation b, and that's 2x plus, well, 3y is 15, and that is equal to 19. So 2x plus 15 equals 19. Well, balancing this equation, we have 2x on this side, and that's going to be 19 take away 15. So 2x has to be equal to 4. Therefore, x is going to be 4 divided by 2. X is going to be 2. Now, we can check, are we actually right? We've used that value to solve our other value, but we're going to need to check, have we actually done it correctly? So let's plug this 2 in place of the x's here. So 3x, what's that going to be? Well, that's going to be 6 in theory, and 2x here, well, that's going to be 4 in theory. So does 6 plus 25 equal 31? Yes, it does. Does 4 plus 15 equal 19? Yes, it does. So in that case, we know that y equals 5 and x equals 2. Now, let's look at this in a real-life context, because that just seems like a neat little mathematical trick, but where might it be used in everyday life? Well, actually, there's lots of situations that it might be used. But one fairly simple example here is an example of 2 receipts. So we have Sam buying 2 coffees and a tea, and the total it costs him is £3.20. We've got Jane buying 3 coffees and 2 teas. The total it costs her is £5.20. That is all the information we have, and we have to work out, what does each coffee and tea cost? Well, what I'm seeing here is that we've got 2 unknowns. We've got a coffee and a tea, and we've got 2 equations. We've got equation A here, and we've got equation B here. Well, let's actually write them out algebraically, because that makes it a little bit clearer. So, equation A, we have Sam. He's bought 2 coffees, so we'll call that 2C, and he's bought a tea. Okay, and that cost him £3.20. What about Jane's equation then? So Jane is equation B. She's bought 3 coffees plus 2 teas, and that's cost her £5.20. Well, thinking about our steps before, the first thing we need to do is find a common factor. Now, we could make our coffees the common factor. Just like before, we could turn the 2 and the 3 into a 6. So we could work it out for 6 coffees in each equation. However, to me that seems needlessly complicated. We want to do this as simply as possible. And the easiest way to do this would be to make the t's the common factor. That means that we don't have to change anything in this equation, and all we need to do is double this equation here. So we end up with 2 teas, 4 coffees, and £6.40. So let's rewrite that just now. So, equation A rewritten, I'll just rewrite it straight underneath. I'm going to multiply everything by 2. We're going to end up with 4 coffees plus 2 teas, and that is going to equal £6.40. So I've rewritten equation A so that we have a common factor. Our common factor in this case are the t's. That means that I can now subtract the equations from one another. So, we're going to have 4 coffees, take away 3 coffees. Well, that's just going to give us 1 coffee. We're going to have 2 teas, take away 2 teas. Well, that's going to leave us with no teas. And then lastly, we're going to have £6.40, take away our £5.20. And when we do that, £6.40 minus £5.20, what we get is £1.20. So we know now that each coffee equals £1.20. Now, we've solved for one value. What we need to do now is use that value to solve for our other unknown value, which will be t. So let's plug our coffee value in. So we've got 2 coffees plus a tea equals £3.20. Well, 2 coffees, that's 2 times £1.20. That's going to be £2.40 plus our tea equals £3.20. And from here on, it is just any normal algebraic problem. So we're going to take off £2.40 from both sides. That'll leave us t on this side, and £3.20 minus £2.40 on that side. Therefore, our t must be 80 pence in this case. So let's check whether or not that makes sense by plugging both values back into an equation. So 2 coffees, well, that's going to be 2 times £1.20, which is going to be £2.40, plus a tea at 80 pence. Does that equal £3.20? Well, yes, it does. So it seems it works for this equation here. What about our other equation? So 3 coffees, that's going to be £3.60, plus 2 peas, that's going to be £1.60. Is that going to equal £5.20? Checking our maths. Well, yes, it does. So in both cases, we know that the coffee equals £1.20 and the tea equals 80 pence. Our steps again, one more time, is just to find a common value first of all by multiplying one of the equations or perhaps both of the equations to find a common value. Subtract one equation from the other to find one of the values. And then lastly, use that value to solve for the other value. Give it a go, guys. It's a good challenge for you, and hope you enjoy it. Cheers!